Hello friends, we members of Dental Study Made Simple channel are once again here to give you a clear and brief understanding regarding dental cements. Hope you guys have understood our previous videos about zinc polycarboxylate cement and zinc oxide eugenol cements. Today I am here to discuss about zinc phosphate cement. The ADA specification number of zinc phosphate cement is 96. My presentation is divided into introduction, composition, available types and biological applications, manipulation, setting reaction, the ways to control the setting time, physical properties, biological properties, the advantages and disadvantages, and biological applications. Now let's get into the topic. I'd like to start with the introduction of zinc phosphate cement. It is one of the oldest cement used for luting purpose, and this cement has the longest clinical track record. It serves as a standard with which newer materials can be compared. Let us now look at the composition of zinc phosphate cement. Powder form. It consists of zinc oxide, which constitutes 90.2% of the powder, and it is the principal constituent. Then comes magnesium oxide, that is 8.2%, which aids in sintering reaction, and other oxides are 1.6% of the total powder, like bismuth trioxide, which helps in improving the smoothness of the mix, and silica dioxide, which acts as an inactive filler. Then comes the liquid form, which contains 38.2% of phosphoric acid, which reacts with zinc oxide, and 36% of water, which controls the rate of the reaction, and 16.2% of aluminium phosphate, which acts as a buffer, and aluminium, that is 2.5%, and zinc, that is 7.1%. Available types and clinical applications. Type 1 contains finely grained particles whose film thickness is less than 25 micrometer, which helps in luting permanent metallic restorations and cementation of orthodontic bands. Type 2. It contains medium grained particles whose film thickness is of 40 micrometer and helps in high strength thermal insulating base. Manipulation. A correct amount of powder and liquid is dispensed onto the cool glass slab. The powder is divided into 4 to 6 increments. The powder is incrementally incorporated into the liquid while spatulating over the large area to dissipate the heat produced during the reaction. Initially, smaller portions of powder are incorporated into the liquid. During the mixing procedure, after the initial small portion, larger increments are added. The amount of heat liberated at this stage is less, as a part of the liquid has already been neutralized by initial small increment. Finally, smaller increments are added to achieve the desired consistency. Thus, the mixing procedure starts and ends with smaller increments in order to control the setting reaction and to dissipate the heat evolved in the reaction. The mixing time is 60 to 90 seconds, and it is sufficient to get a proper mix. When mixed for luting, the cement will shrink, and when it is used for base, it can be rolled into a ball. A proper luting consistency has lower powder to liquid ratio and is obtained when the mix is fluid yet springs up from the glass slab 2 to 3 centimeters as the spatula is lifted from the freshly mixed cement. For the base, it is higher powder to liquid ratio, that is 3.5:1, which has a consistency like heavy putty. Apart from these two consistencies, that is luting and the base, a third consistency that is midway between the two has also been described. This consistency is used for retention of orthodontic bands and has been termed as band seating consistency. Setting reaction. When the powder is mixed with the liquid, the phosphoric acid attacks the surface of the powder particles and releases zinc ions into the liquid. Aluminium from the liquid reacts with these two zinc ions and forms zinc aluminophosphate gel, which covers the surface of the unreacted particles. This acid-base reaction is exothermic in nature. The set material is essentially an amorphous matrix network of zinc aluminophosphate that surrounds incompletely dissolved particles of zinc oxide. Unbound water forms globules within the material, which makes the cement highly permeable, resulting in a porous structure. This material exhibits some shrinkage on setting. The reaction can be presented as the following. The mixing time is 1.5 to 2 minutes and setting time is 2.5 to 8 minutes. This is an acid base reaction and it is an exothermic reaction. Ways to control the setting reaction. Retarders. Calcination of the powder during manufacturing reduces the surface energy of the particle and controls the setting rate. Buffering agents in the liquid control the number of phosphate groups available for the reaction. The use of cool glass slab retards the reaction and dissipates the exothermic heat, which in turn prolongs the working time. Adding the increments in small quantities also slows down the reaction. Accelerators. Increasing the powder to liquid ratio and addition of water also accelerates the setting reaction, decrease in the particle size of the powder and increasing the temperature of mixing atmosphere. Physical properties. The compressive strength is 104 megapascal. The cement has low tensile strength which ranges from 5 to 8 megapascal, hence it is brittle in nature. The modulus of elasticity is 13.7 gigapascal. The cement is highly soluble in water for the first 24 hours after setting and loss of material can range from 2.4% to 3.3%. After this, the solubility is negligible and it is 0.04%. It is more soluble in dilute organic acids. It is quite stiff and resistant to elastic deformation. Adhesion to the tooth structure does not depend on chemical interaction, but it is due to mechanical bonding at the interfaces. It is an excellent thermal insulator and a poor electrical insulator. It is opaque in nature. Biological properties. The cement has the potential to cause inflammation of the pulp, especially in the deep cavities due to the presence of acid. It is hence mandatory to place cavity varnish to coat the dentinal tubules prior to the placement of zinc phosphate cement. Acidity of the cement is quite high during the time of application, that is due to the presence of phosphoric acid 2 minutes after the start of mixing. During initial mixing, the pH rises rapidly with the standard mix reaching a pH of 2 to 4.2 within 3 minutes after the start of mix. It reaches a pH of 6 by the end of 1 hour. The pH reaches neutral at 48 hours. The thinner the mix, the lower the pH will be, and the longer it will take for the cement to return to neutral pH. Pulpal damage can occur during the first few hours. High heat of production during the setting of the cement can also cause pulpal injury. Advantages and disadvantages. Zinc phosphate cement has high compressive strength, hence it is used as a base under amalgam restorations since it can withstand the condensation forces during its placement. It is a good thermal insulator. The cement has relatively low solubility compared to glass ionomous cement and zinc oxide eugenol cement, and it does not dissolve in oral fluids. Disadvantages. It is brittle in nature with low tensile strength. It has high modulus of elasticity. Due to the above two limitations, it cannot be used to lute all ceramic restorations since it lacks flexibility, it lacks chemical adhesion, and retention is only by mechanical means. It is a pulpal irritant due to low initial pH. The low pH causes gross decalcifications which are observed after removal of orthodontic bands luted with zinc phosphate, and it has poor aesthetics. Biological applications. It is used as luting for restoration and high strength bases. It is also used for temporary restoration and for luting of orthodontic bands and brackets. Thank you. If you guys want the PPT of this topic, please do comment below. If you guys like this video, please do like, share and comment, and please do subscribe to our channel Dental Study Made Simple. And for more updates, click the bell icon below.